In this video, we're going to take a look at simplifying radical expressions. Radical expressions, of course, are things where we have square roots like this. And if we're going to simplify them, first of all, it would be good to know exactly what it means to simplify radical expressions. Well, it turns out that radical expressions are in simplest form when there's three things. There's no perfect square factors other than 1. The radicand, and remember the radicand is this thing that's inside the square root, has no fractions in it. And finally, there can be no square roots in the denominator. So let's go ahead and take a look here. First of all, perfect square factors. Well, perfect squares, remember, let me just list out some of those for us. We have 1, 4, 9, that would be 1 times 1, 2 times 2, 3 times 3, 4 times 4 would be 16, 5 times 5 is 25, 36, 49, 64, 81, and so on. Those perfect square factors. If we can break up a square root using one of those perfect square factors, that will allow us to do some simplification. So let's take a look at this first one where we have the square root of 80. Well, I want to look for a perfect square factor of 80. Let's see. 4 goes into 80. Let's see if there's anything any bigger though. 16 goes into 80. 16 times 5 is 80. So we could break that up. So we're going to rewrite this as the square root of 16 times the square root of 5, because 16 times 5 is 80. Now, we can simplify that. The square root of 16 is 4, and then we've got the square root of 5. Now, are there any perfect square factors of 5? Well, let's take a look, other than 1. 1, of course, is a perfect square factor of everything, so we don't even worry about that because that can't help us. 4, nope. 9, too big, so we're done. Now, let's say that you took this 80 and broke it up using the 4. So rather than going square root of 16 times the square root of 5, you said the square root of 4 times the square root of 20. Okay, we could do that. Then the square root of 4 is 2, but then the square root of 20, are there any perfect square factors of 20? Yes, there are. 4 is a factor of 20, so we need to break that square root of 20 up into the square root of 4 times the square root of 5. Then we take that square root of 4, which is 2, so we have 2 times the square root of 5, which simplifies to that right there. Okay, so we get there, but we can get it done in less steps if we look for that largest perfect square factor as we begin to break things up. Okay, let's take a look at this one down here. Well, it turns out that if we've got the square root of a fraction, we can take the square root of both the numerator and the denominator and then simplify from there. But before we do that, we should try and simplify that fraction. See if there's anything I can clean up there first. So as we look at this, we've got 10 over 2. Well, that would simplify to 5. So we have the square root of 5. And then I've got b to the 4th, b to the 3rd. Well, that would simplify to just b. Now I have the square root of 5b. Are there any perfect square factors of that? Nope. So that's it. It's in simplest form. We can't go any further with that one. Alright, let's go up here. Square root of 98x squared y. Okay, so looking for those perfect square factors. 98. Perfect square factors, 98. Hey, 49. Square root of 49 times the square root of 2 gets me back to that 98. Then as we look at these variables, well, x squared would be a perfect square because the square root of that is just going to be x, and then we've got a y here. So let's clean up a little bit. We've got the square root of 49, which is 7, times square root of 2, that we can't simplify anymore. Then I've got the square root of x squared, which is just going to be x. And then I've got the square root of y, which I can't do anything more with that either because it's not a perfect square. Okay, so now I'm going to pull together these things. I can take this 7 and the x, put those together to be 7x. And then this square root of 2 times the square root of y, I can pull those back together to be the square root of 2y. Okay? Let's go down here to try this one. Again, the first thing I want to do is try and simplify within the square root. If I can, I should start there. So I have 40 over 10. Well, 40 over 10, that's just going to simplify to be 4. So I have the square root of 4m to the third over n to the fourth. Okay, and that's all under the square root yet. Now, remember, I said if we have the square root of a fraction, we can take the square root of the numerator and the denominator individually. So I have the square root of 4m to the third over the square root of n to the fourth. Okay, now I'm getting there. Let's see. 4m to the third. Any perfect square factors? Well, 4 is. I'm going to go up here with it. So I have the square root of 4. Now, m to the third. The third power is not a perfect square, but I could break that up like this, where I have the square root of m squared times the square root of m. Okay, if I multiplied those back together, it would be 4m to the third. And then, of course, bring in that 4 if I wanted to. Then on the bottom, I've got n to the fourth. Well, that's a perfect square, because n squared would get me that. That would be n squared. In other words, n squared times n squared gets me n to the fourth. Okay, then we just clean up on top. So we have, let's see, square root of 4 is 2. Then we've got m squared. The square root of that would be m, and then times the square root of m, all over n squared. Okay, let's hop up over here. 45 over 16. Well, start by simplifying the fraction if we can. I don't think we can simplify that. So then I'm going to go to breaking it up using those perfect square factors. 45 perfect square factors of that. Let's see. I think 9. Square root of 9 times the square root of 5. Then on the bottom, I've got the square root of 16. Okay. Then square root of 9 is just 3. Square root of 5 I can't simplify, so that's just like that. All over the square root of 16, which is 4. Alright, last one. 54x to the fourth. Again, looking for those perfect square factors. Let's see. 9's going to go in there. 9 times 6. So square root of 9 times the square root of 6 times the square root of x to the fourth. Okay? Then, going to go ahead and simplify those things. So the square root of 9 is 3. Square root of 6, can't do anything with that. And then I've got the square root of x to the fourth. That would be x squared. I'm going to pull that x squared around front just so we get all the non-square root stuff there. So 3x squared times the square root of 6. Alright, so simplifying radical expressions, we want to use perfect square factors. So hopefully you're very familiar, or you should get very familiar with those perfect squares, because then we can break up any number using those perfect square factors, and that will allow us to do some simplification. To be in simplest form, remember that the radicand, in other words, what's under the square root, cannot be a fraction. There can be no square roots in the denominator, and also there can be no perfect square factors other than 1. So notice here, can't take anything out of that. Can't take any perfect square factors out of 5, out of 6, out of the 2y, out of 5, out of 5. Hope this was helpful. Keep working hard on your math, and I know you'll do great, even if you are a little sleepy sometimes.